We are now at the software stage of the Coding Aviation project. Having completed the assembly videos, we are moving on to programming our human-powered vehicle. The most important thing to consider during programming is to have a good understanding of the flight control equipment we will use and the type of drone we want to create. We want our drone to have the capability for GPS-enabled flight. And in this context, we are configuring our flying motor with 4 motors, 15-inch propellers, and a 5S battery. Why did I mention these details? Because we will need all these details shortly in the initial parameters section. Knowing how the drone we want to build will operate gives us detailed information and insight on the subject. To summarize briefly, the voltage value of our battery and the inch size of the propellers are necessary information for planning how agile and active we can use our propeller, motor, and drone. When we input these into the system, it gives us a more concrete or more aggressive drone output. The first step when starting our setup is to load the firmware to our drone. It's important to load the firmware. For this, after connecting via a Type-C cable, we need to see the found board type message on the screen. After reading this message, it indicates that our board is on COM22. So I'm loading the copter firmware. It recognized my PIX32V5 board here. If it hadn't recognized it, I would need to select it from here. Since I already downloaded it, it gave me a warning saying there's no need to download it again because the software is already on the board. When we click OK and return to the installation screen, we select COM24 and click Connect. This connects us to our drone. The only reason I chose the ON5200 baud rate here is because I'm making a wired connection to my drone. For a wired connection, you need to choose 11520Z, and for telemetry connections, you should choose 56000. When we come to the basic equipment, we select this from the forum tour right from the start. The reason we choose this is that we will use this software. Then we will do the initial parameters part last. We are doing the accelerometer calibration. For this, I'm starting the accelerometer calibration. First, it wants my vehicle to be in a ground position. So I place my vehicle on a flat surface. I confirm. I turn my vehicle to the left. After confirming, I successfully completed my calibration. Once I place it back on the ground, all tasks will be finished. Then I disconnect my connection. I reconnect it. I establish my connection. I renew my connection after each calibration. The main reason I renew the connection is to avoid any issues with the new calibrations of my drone. As you can see from this angle, our drone now responds exactly as we want it to. For example, when we tilt the nose down, it shows the ground, and when we lift it up, it shows the sky. When we turn the drone to the left, it moves left, and when we turn it to the right, it moves right. All right, now let's move on to the flight plan setup. I'm skipping to the compass GPS calibration, which we need to do outdoors. Let's complete the remote control calibration. Our remote control has arrived. Now let's start calibrating. We had already introduced the channels of our remote control while explaining the flight channels. Let's introduce them again. While calibrating our remote, as you can see, this channel represents channel 2, this one represents channel 1, this one represents channel 3, and this one represents channel 4. For the drone to fly, we need a remote with at least 5 channels. The first channel of our drone explains roll, the second channel explains pitch, the third channel explains throttle, and the fourth channel explains yaw. The pitch channel must always be reversed. Yes, that's how these things work, just like our rules. Then we calibrate the radio of our unmanned aerial vehicle. Radio calibration requires great precision. We click and confirm. Our new values have been written to the system. Then we disconnect again. We reconnect. We establish our connection. We go to the Settings tab and then enter the parameter list. When we open the parameter list, many parameters appear. Now I will enter the desired parameters one by one, starting with the CAN D1 parameter. I make sure the CAN D1 protocol parameter is set to 1. Then I check CAN D2. My CAN D2 protocol is set to 1. Next, I look at the CAN P1 parameter. I set my CAN P1 to 1. Then I also set CAN P2 to 1. And I save these settings. Then my parameter. I set it to 9. Then I set the NTF LED value so that it can see the drone CAN. After this, I set my BRD safety switch value to 0. We have successfully saved our parameters. Yes, now I'm restarting my flight control board here. Yes, it has now detected our GPS and is telling us no fix. And as you can see, the LEDs on our GPS are now flashing yellow. Flip-flop. Here, when I come to compass calibration, I see that the UAV CAN GPS is already at the top. This is important for me. It needs to be at the top. Okay, now I can go outside to perform the compass calibration, but before that, I want to do the ESC calibration. To do the ESC calibration, I click on the Calculate ESC button. Then I disconnect my battery. I disconnect the connection. I turn on my remote and I connect my battery. Then I lower the throttle to the lowest point. I bring it back to the top again. I wait for it to beep twice. I'm lowering it, and you can see that they all start at the same time when I give it throttle. As you can see, this is exactly what I wanted. We've completed the ESC calibration, accelerometer calibration, and level calibration of our drone. Now we just need to calibrate the compass. To do that, we'll head to an open area. We have come to an open area for the calibration of our drone. The reason we are in an open area is that our GPS cannot function properly indoors. To start our recording, we connect our drone to the computer. We connect the Type-C cable, which we have attached to our flight control board, to our computer. After establishing our connections through our computer, we connect to our unmanned aerial vehicle at a baud rate of 1V2200. After receiving the parameters, we go to the compass menu from the setup screen for compass calibration. Once on the compass screen, UAV CAN represents our GPS that works with the CAN protocol. To calibrate it, we press the Start button under the MAC calibration section below. Now, after pressing the Start button, as you can see, The lights on our GPS are flashing in yellow, blue, and green main colors in a flip-flop manner. Then we rotate our drone on 6 axes. While performing this rotation, you can also observe that our panels are filling up in green on the computer. As these panels fill up, our compass calibration is completed. First, we rotate our compass fully on the horizontal axis. Then we rotate it on this axis. Finally, we rotate it on this axis as well. After rotating our drone nicely on all axes, our compass calibration is complete. The reason for calibrating the compass in this way is that it operates based on magnetic logic. After the green bars on the screens fill up, our light starts blinking yellow. Then we reboot our autopilot. That means we restart it. Here we press the reboot button and click OK, and our autopilot restarts. After rebooting the autopilot and reconnecting, our compass calibration is complete. Once the compass calibration is done, you will see that our GPS has a 3D fix on the flight data screen. That's it for the compass calibration. Now we will set the flight conditions, and accordingly we will be able to configure the fail-safe for our unmanned aerial vehicle.